First things first, as always, read that question, everybody. We can't get around it. That's the best thing we can do for ourselves. So the question reads, what must be the average speed in miles per hour during the second leg to cover the remaining distance? Okay, sounds good. So there can be some confusion here, everybody, because you might be prone to reading remaining distance, ? And think that we're trying to find a distance. However, everybody, are we trying to find distance here? Correct, we are not. We are trying to find the average speed. So let me, unhighlight all of that. Average speed is what we're looking for. But specifically, everybody, average speed for what? Correct, average speed for the second leg, during the second leg. So notice how this problem is getting even more complicated than the ones that preceded it. But as long as we focus on reading the question first, we're good. We're good. So here we are. We want to know not the first leg, but the second leg, and we want to know its rate. Is that true, everybody? Can we confirm that? The second leg, the rate for the second leg is specifically what we want. Good. Now let's do ourselves a favor and calmly collect the information so we can make some decisions. So here's what we start off on. First sentence, a driver embarks on a 2-leg trip covering a total of 280 miles. Okay, let me go ahead and write that down. That's going to be important information. I already know. So let me write that down over here. The total, and I'm going to say the total distance is 280 miles. Okay, sounds good. Let's keep it reading here. Let's keep it going. On the first leg, the vehicle travels at 50 miles an hour for 2 hours. Okay, so let me highlight that nice and easy. Let me grab blue. So the first leg, which is the one right over here, we see it's 50 miles an hour for 2 hours. So the rate, 50 miles an hour. The time, 2 hours. And before you calculate, remember everybody, before you calculate, we don't want to make assumptions. We want to make deductions. So let's read the rest of the information. Let's take it all down. All right. Next up, it says on the second leg, the journey lasts for 2 hours. Okay, great. So we know that the time for the second leg is 2 hours. All right. So here we are, everybody. We now have everything. Let's ask ourselves, what are we focusing on? The first leg, the second leg, or the total? Where's our focus, everybody? Yeah, our focus, and I know there's a little bit of debate in the chat box, but our focus is the second leg. Remember, it always comes down to the question sentence. What we care about is the speed, which is the rate, for the second leg. So this is truly what I care about. That's what I'm going to hone in on. Now, everybody, check me out. Look at what I'm doing here. I only care about the rate for the second leg. Now, remember how we talked about the consistency that's needed behind the formulas. Remember, we got to be consistent. So if I'm focusing on this formula, while I'm looking for the rate, I do have the time. What do I need to be able to solve for the rate? What extra piece of information here am I missing to get that rate by itself? Correct, the distance. The distance. I need the distance for the second leg, which I do not have. I don't know what this is. However, everybody, is there a way for us to use the information that we were given, like the total between the legs, like the first leg? Is it possible to use that information to get that distance for the second leg? Absolutely. Notice that it's not as easy as just plugging one number in and being done. It's about understanding what you have and what you need. So let's figure out what this distance is, because then we can plug our numbers in and be done. How do we find that? Well, check it out. We know the total distance is 280 miles. If we knew the first distance, we could subtract it from the total and just get the second leg. Everybody, can we get the distance from the first leg with these pieces of information? We absolutely can. We absolutely can. So that formula, as always, is multiplication to get the distance. Distance equals rate times time. The rate is 50. The time is 2. 50 times 2, everybody, is 100. So we have 100 miles right there from the get-go. So help me out. If we know that our first leg's distance is 100 miles, the total distance is 280 miles, what operation did we say we would do? Subtraction all the way, exactly. And so let's go ahead and subtract. 280 minus 100, that's going to give us 180. 180 for the second leg. So this is leg number 2's distance. So I'll plug that in right there, 180 miles. Now, everybody, do we have enough information to find the rate for the second leg specifically? Yeah, now we do, right? Now we do. So we're all set. We'll go ahead and write our formula out. Distance equals rate times time. Plug in what we have, 180 for the distance. Rate stays where it is, 2 hours for the time. What do we do to both sides? Kevin, exactly, we will divide. Great job there. So we're going to go ahead and divide both sides by 2. Cancels out on that right side, giving us the rate by itself as 90 miles per hour. And there we go. Notice how we had to take multiple steps, but everybody, with practice, can you see yourself getting this done in 2.5 or 2 minutes with practice? And that's the point. There we go. You can absolutely get it done in that time frame. We just have to work on repeating the repetition behind the fundamental strategies. Read the question first, read the information, set up your plan. I call it destination plan follow, or what do you want, what do you have, what's the connection? But there you go. So with that said, everybody, are we ready to try one more question out? Right on. Let's go ahead and give it a shot here. So let's get into this one here, my party people. Let's get it out. Let's get it going here. So we have the question stating, what is the diameter of the garden? My party people, is the question sentence clear enough? Do we know exactly what we want? Is it clear enough, right? It is. Diameter. You couldn't say it any clearer than that. We are looking for the diameter. So knowing that we're looking for the diameter, let's understand the information that we're given. So here it says, a circular flower garden has a walkway that starts from the center and reaches the edge, measuring 16 units. Everybody, which one are we given? Are we given the 16 units as the circumference or the area? Which one are we given? Is it the circumference or the area? Man, I can't trick you guys. Yeah, correct. We are given the radius. That's what we're given. So right here, let me highlight this. It says the walkway starts from the center and reaches the edge. So if we're going ahead and illustrating that right there, the walkway starts on the center and reaches the edge. It could be any edge, but starts from the center and reaches the edge. That is the definition of radius. And now that we have the radius being 16, everybody, what do we do to the radius to get the diameter? What do we do? That's right. We multiply it by 2. We double it. Remember that the diameter is double the radius. So to get our diameter, with mental math or on paper, it doesn't matter. We'll have that radius of 16, multiply that by 2, and we'll get 32. So that is our diameter. I know it's a quick one, but I definitely wanted to keep you on your toes with this problem. See 32 units, and we're good to go. Notice that I'm really pressing you on understanding the key words that you're given. That's really more important than being able to calculate. So with that, let's turn our attention over to the next problem, nice and easy.